Alright, so this is the Unit 9 Part 2 practice test, and let's just have at it. Alright, so I've got to solve this equation. It's a quadratic. A is 1, so I wonder if I can factor this. So negative and a negative is a positive and a negative, and can I make negative 2 with a factor 15 with a positive and a negative? Well, I can make 3 and 5, so yeah, I think I can. So let's go ahead and see what happens. So I'm going to say 0 equals, and then it's a negative and a negative sign, so it's going to be a negative and a positive. It's just 1x squared, so it's going to be x times x. Now I need the factors of 15. That'll make negative 2. So let's see, 3 and 5 will make negative 2. 5 needs to be negative. It matches the second sign, right? So that's going to be 5 and 3, and then negative 5 plus 3 is negative 2. Right? If you want to tic-tac-toe that, you'll see that x minus 5 and x plus 3 is x squared minus 5x, negative 15, 3x. Those two make a 2x with x squared and negative 15, and those are my three terms. So that's right. Okay, so if all this equals 0, then this means that x minus 5 equals 0, and it means that x plus 3 equals 0. So that means, therefore, x equals negative 3 and x equals 5. 5 and negative 3. All right, that's the first one. Moving on to the second one here. Oh, I have something squared, right? So that's telling me that I need to get everything to the other side that is not in this term. Right, there's the variable term from there to there. All right, so let me move the 19 to the other side. It's negative here, so it's going to turn into positive 19. No longer on that side. So it's going to be 2 times the quantity of x plus 5 squared equals 3 plus 19 is 22. Okay, now I need to get at this x first, but that 2 is preventing me from getting at these parentheses all by themselves. So I'm going to divide both sides by 2, and then I'm going to get x plus 5 squared equals 11. Okay, so now I'm going to take the square root of both sides, right, to get at that x. So if I take the square root of that and the square root of that, I get x plus 5 equals a square root of 11, and that's the most precise number. I'm not going to put that into a calculator and make it a decimal. I'm going to keep it as precise as possible. So now I just need to move this to the other side. Oops, I almost forgot. When I take the square root of something, it's plus or minus the square root of 11. Almost forgot to do that. All right, so it's plus the square root of 11 and minus the square root of 11. Moving the 5 to the other side, I get x equals the square root of 11. That's positive 11 minus 5, and x equals negative square root 11 minus 5. And that's going to be what I put in here. I put in square root of 11 minus 5, and then the negative square root of 11 minus 5. If you put a plus sign right there, it's not wrong. Okay, it's just not needed. Okay, so here's this one, and let's see. If I divide stuff, I need to get this to be 2 or to be 1 if I want to. I mean, I could factor it maybe and slide and divide. That would take some time and it might not work. I could complete the square, moving the 3 over there, but then I'd end up dividing 7 by 2 and then having to square it. That's going to be messy. So I'm going to use the quadratic equation on this one. Okay, that's probably going to be my shortest answer, or the shortest solution to the answer. right? So remember that x equals the negative value of b plus or minus the square root of b squared minus 4ac all over 2a. Remember that negative, it means it's the opposite of. All right, so let's identify my a term. My a, my b, and my c. A is 2, b is negative 7, and c is negative 3. All right, so I'm going to first start with just doing the radical part of this, because that's really the only thing that's going to change, right? I guess I can do the other ones first. So I'm going to have two solutions here. I'm going to have x equals and x equals, and my negative b is 7. Okay, so it's negative negative 7, so it's the opposite of that. And then 2 times a is 2 times 2, which is 4. And it's going to be plus the thing that I'm going to do here, and then minus the thing that I'm going to do right here. Well, let's do that thing right here, the radical stuff. All right, so it's going to be the square root of b squared. It's always going to be positive, right? Because negative 7 squared is 49. And it's going to be minus 4 times a, which is 2, and negative 3, right? So let me move this over so it's a little bit neater. Okay, so let's see. Let's do negative 3 times 2 is negative 6, times negative 4 is going to be positive 24. So this is going to be the square root of 49 plus 24, which equals the square root, let's see, that's going to be 73, square root of 73. And all the 73 is a prime number, so I can't really simplify that. So it's going to be plus the square root of 73 and minus the square root of 73. So there we go on that one. Okay, I'm just going to leave that there and put a big box around my answers right there. Okay, so there's that one. All right, moving on to number 4. Well, first I'm going to put this into, see, the factors of 9. No, this would be the factors of 8 that would make 9. Maybe this will work. So I'm going to move this over here, put it in standard form. That's going to be x squared minus 9x plus 8. So I need the factors of 8. That'll make a negative 9, right? And it's going to be a minus minus. This might be possible to factor. So I'm going to do x minus and x minus, right? So 8 is, I got 8 and 1 make 8. And negative 8 times negative, let me double check this just to make sure, but I think I factored it. X minus 8, x minus 1. They're not always factorable. X squared minus 8. This is going to be plus 8. This is going to be 8x, excuse me. And this is going to be minus x. That makes it negative 9x. Yeah, so that's the way I'm going to do that one. So this all equals 0, right? Because I moved this over to make it that this equals 0. And so that equals that. Okay, so now I just say x equals negative 8 and x, whoops, that's not right, x minus 8 minus 8 equals 0. Don't make that mistake. Okay, and I know x minus 1 equals 0, so x equals 8 and x equals 1. So x equals 8 and 1. So there you go, there's that one. Okay, moving on to this, number 5. All right, looks like I have this equation that represents the number of housing units sold in Y in thousands. So the number of housing units sold, it tells me, is Y. Let me make in the margin here a little. This is the thousands of houses sold. Okay, and then this is year 2000 or year 0. Okay, and then X is the year since then. And it's saying, hey, this models the equation. All right, so what are my constraints? Well, I drew this quadrant here, right, because I'm only going to be operating in quadrant 1 of my coordinate plane, right? So that means that x must be equal to or greater than 0, right? So that, and then all the way up to where my x stops. So I know it's going to be at least greater than 0. So all values of x such that 0 and is greater than or is less than or equal to x. Okay. Now let's see. This is going to be a concave up, right? So if this is concave up, right, it's gonna just do this forever, right? And it doesn't tell me, oh, 2025. 2025 is my maximum, right? So that's 25 years after 2000, so that's year 25. That's where my data set is gonna end. And it is an element of all integers because we're talking about years here, okay? All right, so now we're gonna, remember this is in vertex form here, okay? So in vertex form, this is the x value or the y value of my vertex, and that is the x value of my vertex. All right, so my vertex is going to be at 16 years. So this is 25. So 16 years. It's like let's see, halfway is 12 and a half. So 16 years is like right here. Okay, so it's 16 years. It was almost 4,900,000 homes sold. Let's bring that down a little bit. It's a minimum, so no reason to bring it so high. All right, so this is 48,999,000 homes sold right there. So concave up parabola does that. Okay, so that's my minimum value. So there's nowhere that the line exists below my y value of 48,999,000, right? So I'm gonna say, hey, my y value, my is gonna be all values of y such that y is greater than or equal to 4899, and that is that. All right, and this can be well, integers really, right? Because I can't sell part of a house if you really wanted to get into that. Okay, so worker explanation, I already kind of said it. Hey, my minimum years is 0. My maximum years is 25 minimum because that's where my data set starts. And this is where my 0 minimum, this is where my data set ends, right? Right, because it's 0 to 25. That's really just setting my constraints. If it wasn't for those constraints, this would go on forever in both ways for infinity and negative infinity x. But it's restrained to 25 years. So like right here, this looks more like that. Okay, so now my y, well, this is the minimum value. My 4899 is minimum value of the parabola. Right, so it's the minimum value that was reached during that time frame. Minimum, or not value, but the minimum number of houses set within the domain. Right, so the domain is this, but it was the minimum within the domain, and it's the minimum of the parabola. Okay, all right, so next one is saying, hey, determine when it was this much, right? So I know that I can say that 6179,000, I'll put a K right there just to say 1,000, right? Not 6179, but 6179,000. Okay. Equals, K means 1,000, by the way. 5 times x minus 16 squared plus 4,899,000. All right. So remember, x represents the year, right? And that's what I'm trying to solve for. I'm trying to solve for x. Okay. Trying to find what year. Remember how south is. Determine the number of housing units sold in southern states. So you work. Determine when the. Oh yeah, when the year. When the year. Okay. So it's asking when this was. So when on here is did it sell 61? So I'm gonna get at least one solution. Maybe I'll get two if it's not inside the constraints. Okay, so let's take a look. All right, so I'm going to move this over here, minus 4,899,000. All right, let's see, I can do that. I'm going to pause this while I get a calculator. So I got 6,179 minus 4,899 is 1,280. So 1,280 equals 5 times x minus 16 squared. Now you need to divide this thing by 5. Let me change the color. Divide this by 5. Divide this term by 5. That way I get rid of the 5 in front of that. And I'm going to divide this by 5. And it's going to be 256 equals x minus 16 squared. And I got to take the square root of both sides. So 256 square root. Remember, it's going to be plus or minus 16 equals x minus 16. Well, there you go. All right, so I'm going to move this 16 over here. I'll move it up here. Okay, so I know that x minus 16 equals positive 16, and x minus 16 equals negative 16. Okay, so, well, let's see here. I'm going to have a x. I'm going to bring that over there. It's going to be x equals 16 minus 16, which is going to be negative 32. I wrote a 36. Negative 32. And then it's going to be x, it's negative 16 plus 16, so x equals 0. Right, so at year 0, or 2000, this thing was at 0. Right, because I don't have any data before. I don't have any data before then. Okay, so there is that. Okay, so I hope that this makes some sense. Oh, let's go to the next one. We got one more. All right, so here we have some numbers. And it's 2, 4, 6, 8, 10, 12. All right, let me see if I have any. Oh, here's the same number. There's the same number. Here's the same number. Here's the same number. And they are 4 and 4, or 2, excuse me, 2 and 2 away from 10. And 6 and 4 and 4 away from 10. So that there is my vertex. Hey, look, it's my vertex. It showed me that. It's already there. Okay, so models the term of haircuts cost. All right, so let's see. I got the cost of haircuts as my x. And then what is my y? Charges. That's not spelled right, but that's okay. It's a practice test. Revenue, the barber, the base quadratic models of the base haircuts cost shown. Okay. What is y? Expected revenue. Oh, this is the expected revenue. All right, so this is the expected revenue. Okay. So when the haircuts cost this much, this is how much he expects to make on some amount of time. Doesn't really specify. Okay, use a quadratic determinant to determine how much he should charge to make $6,075 per week. right? So we want 6,075 equals negative 100 times x minus 10 squared plus 6,300. So again, the same process as last time. Move this over here. It's going to be minus 6,300 equals, nope, it's going to be equals negative 100 over x minus 10 squared. So that is going to be 6,075 minus 6,300, and it's going to be 6075. Okay, so it's going to be negative 6075 minus 6300 equals negative 225. Oh yeah, okay, 225. Okay, so yeah, negative makes sense here because if I look ahead, I'm going to end up dividing everything by this negative 100. Now negative divided by a negative, I had a slight hesitation there in my math because I got a negative number that I anticipated taking the square root of, but it's not a negative number. It's 225 negative divided by 100 negative, which is 2.25 equals x minus 10 squared. Okay, so now I got to take the square root of both sides. Take the square root of both sides. Now let's take the square root of that. It is 5 1/16, or 81/16. 81/16. That's ugly. I'm going to have to subtract 10 from that. I don't want to do that. Let me go back to a decimal, I guess. So this is 5.0625 equals x minus 10. So it's going to be x minus 10 equals, remember this is plus or minus, right? Plus 5.0625, or x minus 10 equals negative 5.0625. Okay, so now I'm going to move this over here to make it plus 10. Move this over here to make it plus 10, and I will get, oh, this is a years and something. Okay. All right, I'm solving for the years either way. All right, so what years were these things? Okay, there's some issues in this word problem, but that's all right. All right, so I'm going to go here and say year 2 is was negative 200. This is going to be like this because it's a negative 1. Oh, you can't see what I'm doing. That's what that model is going to look like. And at 10 years was the maximum. So at 10 years, it was a maximum. It doesn't give me a written constraint. All right, so anyway, back to the problem. This is going to be, let's see, so x, I'm going to go ahead and truncate this because I'm not going to calculate in a couple months. I guess I could. 0.0625 is 1/16 times, so 1/16 times 256. 1/16 times 256 is 16 days, but whatever. All right. Anyway, that's 16 days. That's insignificant, so I'm not gonna bother that. Like I said, I'm just gonna truncate that stuff. All right. So I'm gonna bring this over and get x equals positive 15 years, and x equals no, not positive 15, positive 5. Positive 5 years, and then x is going to be negative 15 years. So I think I'm going to rework this one because it's going to be at 15 years, a year 15, because unless I'm missing something in here, it does not identify a starting year. So that is that. I'm probably going to revisit that one. Someone must have wrote this in a hurry. So I'll go back and look at it for him. All right, anyway, that's how you do the stuff. I hope everything makes sense there.